Greetings, and sorry on that last video we got cut short by about 4 or 5 seconds. I wish Mr. Bill didn't interrupt. But what we had, and we were just about to cap off, was the fact that if we did not recognize this right here as tan 2 theta, we would have bulldozed through, or did our double angle identity for tangent, and found that as we went through the process we'd get the same exact answer. So we are in the process of flipping or multiplying by the reciprocal. We would have been able to reduce, getting a 5 times 24. 5 times 24 would have in fact given us our negative 120 on top. On the bottom, we would have then had a negative 119, which you all recognize as our positive 120 over 119. All right. So let's move on to the next problem. Last example we'll have for this section. Last example, yay! What do we have? We have a sine u of 3/5, and we have a restriction. Our quadrant, then, we notice right away, would happen or take place in quadrant 1. So that's an important restriction to remember. Now, our sine u is giving us a y value of 3 and an r value of 5. Remember, radius or hypotenuse. And so we want to know what is our x value. Our x value, if we work our trig identities out, we will get either a 4 or a negative 4 would work. And in this case, because we're in quadrant 1, we're going to take the positive value and kick out the negative 4 value. So there are 3 values in which we can use for our trig identities. Sine 2u, one more time, is 2 sine u times cosine u. And we can substitute in then, and we know where we're given what sine u is. That is equal to 3/5. We can figure out what cosine u is, x over r, which would be 4 over 5. And if we do the math real quickly, we end up with 24/25, or 24 over 25. And again, remember, we're finding a value, not an angle. Looking at the cosine 2u identities, I'm going to just use 2 of them just to show how they work this time. We could use 1 minus 2 sine squared u, and that's nice and effective because we already have what sine is, so we have a 2 times a sine u of 3/5, and we simply need to square that. And if we square that, we'll find we have a 1 minus an 18 over 25, which gives us the answer of 7 over 25. Now, I'm going to just grab one of the other identities, doesn't matter which, so let's try the 2 cosine squared u minus 1 identity. And in this identity, again, I should get my 7 over 25. Let's work this out. I have a 2 times, in this case it was a 4/5, and we'll square it, subtracting 1. That will give me a 32 over 25 minus 1. And that 1 could obviously be written as negative 25 over 25. Like denominators, gives me, one more time, a value of 7 over 25. So we should be feeling pretty good that we get choices with the cosine. Now the tangent, not so much. As we talked about last time, you might recognize this as sine 2u over cosine 2u. And we're only doing this because we have solved it already. If we didn't solve for a and b, I wouldn't recommend rewriting it like this. But rewriting it like this, we end up with a fraction for sine 2u of 24 over 25. all over the fraction 7 over 25, which the result is then 24 over 7. Getting used to this double angle for tangent, however, let's just see how that works out. We end up with 2 tangent of u all over 1 minus tangent squared u, which results in the following complex fraction. We get a 2 times a 3/4 in the numerator all over 1 minus, and it looks like we're going to square that 3/4, so 1 minus 9 over 16. Doing a quick reduction here, I do have the fraction 3/2, and that is all over 7/16. If I multiply by the reciprocal, this will get me back to 24 over 7. So that is perfect. We're done with the lesson. We need a couple practice problems to bring to class, and they are these. So please work on these for class tomorrow. Would like you to evaluate cosine 2x plus sine squared x equals 0. And number 2, we're going to evaluate both sine 2x and cosine 2x, or rather sine 2 theta and cosine 2 theta in this case, when we have cosine theta equals -3/4 and it's on the interval pi over 2 less than theta, which is less than pi. So remember to look at this and determine what quadrant we are limited to. That is always very helpful. And remember, what do we have for an x, a y, and r values? So that should be somewhat of a hint for you. Good luck, and we'll see you tomorrow.